Welcome to Google DeepMind, the podcast with me, your host, Hannah Fry. Now, you might remember that earlier this year, I got to sit down with Carolina Parada, who is the head of robotics at Google DeepMind. And she was talking all about taking Gemini's multimodal reasoning and embedding it into a physical body. And since we were coming to California for this trip to see what Google DeepMinders are doing on this side of the Atlantic, obviously the robotics lab was top of the list. Now, you have to remember that these robots aren't these fancy pre-programmed robots that are doing backflips, right? This is something completely different. These robots are open-ended. They are understanding the instructions that you give them and then able to flexibly respond and adapt to an unlimited number of tasks. Now, our tour guide for the day is Kanishka Rao, who is the director of robotics at Google DeepMind. I haven't been into a DeepMind robotics lab since, I think, 2021.
Oh, okay.
Already it looks quite different. You haven't got the privacy screens.
Yeah.
They've gone.
They're gone, yeah.
You don't need them anymore?
No, we have the whole lab here in the open.
Is it that they're more capable of focusing?
Yeah, the models are now trained with much more robust visual backbones. So we don't care too much about the lighting or the backgrounds as much. So the visual generalization part of the problem is much more solved than 4 years ago.
Big improvements?
Big improvements, yeah.
Okay.
There have been a few big breakthroughs in robotics in the last couple of years, and we're excited to show those today.
Yeah, it might only be 4 years, but it's basically an ocean of time in terms of what's changed.
Robotics looks very different than it did 4 years ago.
What are the big changes then? Large language models, multimodal models.
Yeah, so basically we want robots to be general. And to be general for human usage, these robots must be able to understand, general purpose, human concepts. And the big breakthroughs in the last few years have been, we're kind of building robotics on top of these other bigger models, these large vision language models. And turns out they have great understanding of general, world things. So the latest robot models are now built on top of that. So we're seeing incredible improvements in how they generalize, new scenes and new visuals and new instructions. So yeah, robotics is way more general than it was a few years ago.
Because I was talking to Carolina earlier this year, and she was sort of saying that it's not even just vision language models to perceive the scene around, but also to plan the actions that it's doing. Yeah, so basically we develop these things called VLAs, which are vision, language, and action models. Mm-hmm. So what we did with those is we put actions, which are physical actions that the robot is doing in the world, and put them on the same footing as the vision and the language tokens. So then now these models can, model these sequences and try to figure out, if they're given a new situation, what are the new sequence of actions to do there? So we call this action generalization. And even in this, we've seen, massive improvements in the last few years. So in the previous release, you saw robots doing kind of more short horizon things, like pick up things and place them somewhere else, or unzip a bag. But really to be useful to humans, you want longer horizon things. And there we have an agent now that can orchestrate some of these smaller moves to make it a much more longer horizon thing. You want to pack your luggage for London, you want to first look up the weather in London. So this agent can then check the weather, decide what you want, and then even pack your bag for you. So it's you've got this kind of fundamental layer, that sort of foundational model, and then you're building on top and on top and on top and on top until you can chain sequences of actions all together to do a long, complex task.
Yeah, and it makes it way more useful because you don't want that short horizon thing. What you really want for a robot is to do the full thing for you. So this agent really brings that other layer of intelligence to the whole thing.
And this is 1.5.
Yep. We have so there's two capabilities in 1.5. We have the agentic component, and then we have the thinking component. And thinking is a word that's been used a lot. So for robotics purposes here, what we're trying to do is we're making the robot think about the action that it's about to take before it takes it. So it'll output its thoughts, and then it will take the action. And just this act of outputting its thoughts makes it more general and more performant because we're kind of forcing it to think about what it's going to do before it does it.
Because you see this in language models, right? Take a deep breath before answering, or the chain of thought, ideas does actually improve the performance. But it's the same in robotics.
It's the same principle that we're applying to robotics and physical actions.
Isn't that weird? Just some of these emergent properties are just so weird.
Yeah, for robotics, to do basic manipulation tasks is really difficult. So we do these tasks very naturally, intuitively, without thinking about it. But for robots, it's hard. So getting it to think about these actions before it does it, it truly helps the robots.
Amazing. Okay, well, obviously I want to see. Can we go see one of these ones?
Let's go.
Okay.
So let's take a look at the Aloha robots here. And here, it's going to pack us a lunch with some very dexterous moves. and it'll do like a long horizon task.
Amazing.
And it's Kaden who's going to unload the robot.
Kaden, thank you.
So this is going to pack a lunchbox, and this is one of our most difficult tasks because it needs to know like the millimeter level precision of like grabbing the Ziploc in the correct way.
Yeah.
And then like it'll try to get the bread in that tiny spot.
Oh,
and
wow.
it's just all visual servoing.
Oh my gosh. I'm so impressed. I mean, as soon as I said the word impressed, it started flailing slightly. But
That's stage fright, yeah.
And does it correct itself?
It'll keep trying.
Hey, hello, you got lots of cameras pointing at you. I understand.
Yeah, they
I understand the stress. The first time I went into a DeepMind robotics lab was maybe 2017 or so.
Okay.
And at that point, they had, like the big Lego for like toddlers. All they were trying to do was like stack one on top of the other, stack blocks. And honestly, the pile of discarded broken Lego in the corner was like illustrative of just how difficult. Yeah. But this idea of like millimeter precision for the bag.
Right.
Wow, look at that.
Nice, okay.
No way. I'm so impressed. Go on,
try it from the top
give it another go.
Yeah. We want to see the bread in the Ziploc. Too much. I'll try to do the... Okay.
Oh, that is so... Almost. Wow.
All right. Yeah.
That's
nice.
amazing. That's amazing. Because it crushed too hard on that and you wouldn't be able to close it.
Yep. And it's
and too soft, you're not going to be able to.
Some more stuff.
I mean, that was easy. The chocolate bar. And now the grapes. Is it going to go on a grape? Oh. Almost certainly that's some grape juice going on there. This is really impressive.
So this is the dexterity in action, like just like how precise it can get.
Okay, so...
And then it's going to try to close it, I think. Yeah. So this is just learn from the data how to do this. This is just end to end. So,
but exactly end to end, as you say, right?
Yeah.
Like
this is just vision and actions.
And what kind of data is it learning from? I mean, it's not going to do the zip, is it?
Let's find out.
What kind of data do you give it? So is this based on just allowing the robot to try lots of things, or are you simulating?
So this is actually done via teleoperation. So we kind of embody the robot and do the task with the robot, and it learns through that perspective, and it is going to... So it can pack you some lunches. Yeah.
So you've demonstrated to it, this is what it means to do it correctly.
Yep.
I see.
All right. Thanks. That was so cool.
I sort of want to give you a high five, but your hands are quite pointy.
Yeah, not these ones. Okay, so we saw dexterity here. Let's take a look at another demo where we'll showcase the generalization capabilities of these robots. We talked about how VLMs are general world understanders, so we'll see that on robotics now.
Because that one was a task that it does over and over and over again to try
It's more about the dexterity. Here, it's more about the generalization.
Okay.
So Colleen here is going to show us what the robots can do in a more general setting.
So here we have our robot running a general policy, so it can kind of interact with the objects, and you can just speak to it because we have a Gemini layer on top. Amazing. So, for example, hey, can you put the blue block into the blue tray?
I am putting the blue block into the blue tray.
Oh, it's chatting while it does it.
Yeah, so if you want to just ask it to do something, it's a push to hold mic.
Yeah. Can you put the green block in the orange tray, but do it as Batman would?
Nice.
I cannot perform actions as a specific character. However, I can put the green block in the orange tray for you.
Fine.
I am now moving the green block into the orange tray.
Okay, that's cool. So if this is completely generalizable, okay, so I have a stress ball.
Okay.
That I travel with, and it's never seen this before.
It's never seen that
so
before.
if I put that in the scene,
okay,
and that's a pot, right?
Right, this is a little container and it lifts open.
Okay, let's try this. Open the lid of the green pear.
I'm getting started on opening the lid of the green pear.
Oh, it's going to be tricky. Ooh, that is difficult, right?
Yeah.
That's small.
All right.
Amazing. Place the pink blob inside the green pear.
I'm working on placing the pink block inside the green pear.
It's like a bit difficult.
Oh, nice.
Go on. Oh, I want it to succeed so much. Oh, squishy.
Yay. Okay.
Put the green pear lid back on the pot. Yes. Oh,
Nice.
so impressed. You know what? You look like a proud parent.
No, it really feels that way
It's
sometimes.
amazing. It's amazing. Never done that before.
Yeah, that pink stress ball is never seen before.
Yeah, the open-endedness of this
Yeah.
is really extraordinary.
Yeah.